Hi guys. First, I'm flattered you guys took an interest in my project, so thank you guys for coming. In this presentation, I'm going to tell you about how I combined a Raspberry Pi and a projector to make an interactive board game. Now, no project is ever quite done, and this is a hobby project, so let's call it a playable, workable prototype with ongoing changes. Perhaps it's more accurate to call it a Python projector Raspberry Pi board game. A little bit about myself. So I drove up from Toronto on Friday with a good friend. I live downtown in Kensington Market. If you guys ever want to drop by and talk Python projects, please feel free to drop me a line. Outside of Python and work, I'm an avid long-distance runner. If anyone else is a long-distance runner in this room, you'll know that also comes with a love of cuisine. I did my master's in physics at Guelph, and after that I signed in blood and started working for a bank, where I now do predictive modeling. I use Python, although I'm one of the few who does. The bank is a great place to do that because they've got a lot of really good data, both internal in terms of transaction data and external data they buy from other companies, and it's really clean, so it's like a really great learning environment for machine learning. It kind of became known that I was using Python, and so eventually my boss's boss's boss, because that's how banks work, asked me to kind of give a pitch on Python and whether we should consider bringing it into our company and whether we should use it. So I totally jumped on this opportunity. And this was a good time to kind of dig up an old project of mine. And that's the project I'm going to tell you about today. There's kind of two parts to it. The first is the motivations, why I did this, why I thought it was important, the reasons I kind of went in the direction I went, and to tell you about the game itself. Then I'm going to get into kind of the mechanics of the system which does the processing, which is the keystone of this game. It's the way it detects tokens and tracks their movement across the board. I'm going to break this down into three kind of problems to solve, or hurdles to get over, including inventing some distinguishable tokens, which we can use in our game, knowing where the camera should look for these tokens, so kind of translating between the camera world, or the image world, and the projection world, so you can coordinate basically two coordinate transformations. And then identifying these tokens that we have. I'll briefly touch on the modules and libraries I leveraged, or at least the ones that are kind of specific to this project. Disclaimer, this is my personal project, so please just respect any library requirements that are in there, but my code is all on GitHub, so definitely take a look, steal anything you can, and help yourself. To start with this, I'd like to tell you about the original game I built. This is not this game. This is a hard-coded game, or a physical board game I built like years ago. And it was utter garbage. I thought it'd be so cool. There'd be so many pieces, there were so many components to it, but it ended up just being completely unplayable. There were innumerable tokens, turns took impossibly long times. It was just basically unplayable. 4 hours into playing with a group of friends of mine, we realized that none of us was actually any closer to winning than any other. So we just kind of had to scrap it and go for beer. So I shelved this project. But I think I learned a few things from it. So before I did shelve it, I put down a few things that I thought were interesting about board games that I thought that this game had missed. Things that I thought would be a good guiding light for if I ever did build a better game. This is what they are. Any board game I wanted to build would be quick to set up. It shouldn't require reshuffling tokens or making sure cards were sorted, or even figuring out who should get what cards to start with. It should operate on simple rules, and they should be intuitive. Just like if you're programming a function in Python, that function should be intuitive to the user. It should be obvious what it does. Same thing with the game. It should be pretty obvious what you're doing in the game and how to achieve the objective. It's just the subtleties of the game which make it more complex. If I'm spending 5 minutes tracking tokens and moving them around and making sure that all of my things are kind of processed and kept track of, I feel like I'm losing something in the game. I want the minimum threshold between the idea for the move I want to make and actually implementing this move on the game. It should be tunable. My game certainly wasn't. I had printed everything, it was all hard, and if I wanted to tweak all the knobs that kind of adjust the gameplay, for example, the strengths of the units or what technologies are available, how to upgrade them, it was impossible. Well, not impossible, it took extra work. I don't want to do extra work. The third is it should be reusable. So if I'm going to invest time in making a framework for a game, I would like it to be something I can actually leverage for other games. It shouldn't all go into one single project, which is a single game. It'd be nice if I had something I could copy and share and reuse and make multiple games with the same system. And finally, it should be engaging. Simple graphical cues can have a huge effect on the immersive experience of the game. It could be just sounds or images, but you definitely need something visual. You might notice that 3 of these things in this list lead really well to Python. If I could make something that was within Python, it could be easy to track tokens or pieces or stats. It could be easily tunable as quickly as changing a variable. And the framework could be totally reusable, especially if you modularize to make the framework consistent or encapsulated, which I've tried to do in this process. So now you know the guiding lights behind this game. Let me tell you about the game itself. This is kind of like the garage mock-up version of the prototype. It consists of a projector, a camera, and a raspberryPi. The projector projects the board. It's a turn-based game, so then you will go down, place your tokens on the board, which will be processed by a camera at the end of your turn. It keeps track of what all your tokens are and where they move. It then feeds that data into the Raspberry Pi, which will update everything on the projector. So you can basically make your moves turn by turn, and it'll interact with you on the board. This is what it actually looks like, or at least my implementation. The key things to note, and totally there's many ways to go about this, are that there's these things I'm going to call key points on the board. These are the points at which you can actually look for a token. So if I place a token, for example, in the control board, each player has a control board on the side. At the end of my turn, when I click to process, it should activate whatever that effect is. So for example, allying with another player, or in the case of player 2, whose turn it is, you can see they've got a random grab bag of technologies that are available for them to purchase. Very easy to just put the token on, and it'll be handled all in the background. That's one of the places you can put these tokens, these key points. Another set of key points is actually on the board itself. I used hex tiles, and to understand this, let's take a little closer look. Within each hex tile, there's 3 places I decided I should be able to put a token. These are the key points. This is where the camera is actually going to scan for any particular token. In this case, player 1 has put a token down on one of these key points, nicely invisible mysterious token, because we're going to get to that later. And it's created at the end of his turn a ship for him. That ship is now tied to his token. If he moves the token across the board, the ship will follow him. Initially it was a generic token, although it was unique. But now by actually creating the ship, he's actually registered it to himself. And it will be his token as long as he uses the game. So it's like absolutely minimal effort in terms of shuffling tokens. Now that you kind of get the basic idea of the framework of the game, I'm going to tell you about how I've solved the 3 objectives. One is to invent some distinguishable tokens to actually use in the game. That mysterious dark blob you were seeing in the previous one is the token. Next is to calibrate where the camera should actually look for these tokens. So translating between the camera space, or the image, and the projector space and what you're actually projecting. It has to line up perfectly, otherwise you're going to be looking in the wrong spot. And finally, to implement a method to actually identify the distinct tokens. So once we've got the tokens on the board, we're scanning for them. It should be a pretty simple system to actually identify which token is which and where they are. So the first step is to make a set of distinguishable tokens. There was a lot of ways I thought about doing this, especially when I was doing a physical board game. Things like, should I use an RFID chip to identify each one, and then at each key point location there's like an RFID sensor, and they're all unique, so you can move them around and it detects where they are. Maybe use a QR code or shapes if I'm looking at a camera. So maybe the camera way back there can identify what the QR shape is, or the whatever it is. Or LEDs. I was getting crazy here. LEDs which flash a consistent signal, and so the camera watches for that signal and then can see where each piece is based on the signal it's emitting. But these all seemed a little more challenging, so I went the easy route, especially because there's tutorials for image processing online. So I went with color. I took 5 base colors, and I printed them off into squares, and these become my prototype tokens. Ideally, if I can get Python to recognize each of these squares individually and move them around on their own, I should have 5 unique tokens that can be tracked throughout the game. Unfortunately, having 5 unique tokens is not a lot of tokens. was hoping for a little something with a little more grandeur, something where you can have many pieces, many ships, each of which has its own unique stats. So I need to improve upon this system. One way to do that was to start combining these tokens. If I combine the two bottom tokens, I get this sixth token. Conceivably, as long as I can identify each of the base colors, and they're all unique, this extra one should also be unique because I can track that there's two colors in it and which two colors they are. You can iterate this process, basically splitting all these base tokens into 4 different colors, and generate a list of 30 tokens, which you could use. I whipped up a Python script, which basically quickly churns these out, and quickly you get like all the tokens you would ever need for a game on paper, so prototype style. But I gotta warn you, I'm glad I made a script to actually make these images instead of trying to like paint them or do anything, because the image changes a lot. Between when I actually generated this image with Python, and then I printed it, and then scanned it with a camera, all of these color ranges shifted like crazy to the point where some of them were totally indistinguishable. So I had to do a lot of tweaking to make sure that the colors I was actually printing, even though they might have been pretty close in color space, were distinct when the camera got to them. So it took some shifting. It also is really handy to include a feature such at the beginning of the game. It calibrates on each of the colors to start with. It takes into account mood, or lighting, or whatever you might have in your den. So now we've got a list of tokens. The next step of the game is to scan for them in certain key point locations. OpenCV came in really handy with this. Between image subtraction and simple blob detection, you can basically track where all these things are. The idea is that I want to be able to look on the key point locations, but not in between, especially because if I look in between, there's a good chance that I could be registering half of a token and falsely identifying it. So it has to be very precise. You have to look exactly where the token is going to be and not where it's not. To do this, let's take a look inside the camera's perspective. So we're going to step inside the camera right now. And this is what the camera might see. You can see my windows on either side, my living room, and here's the screen of projector. You might recall that there are 3 key points in each hex tile. Here I've had the projector highlight each of the key points in a column of hex tiles. The idea is I want to know where they are. I want a system which I can translate where this point is in the projector space to the camera space. I do this by first taking a picture with these spots highlighted, and then ones without. And then you do image subtraction, which basically takes pixel by pixel, you subtract the 2 images, and you get a very impressive, stunning, these are the dots I wanted to see, and it's amazing how quickly they come out. You can do some processing to make them brighter. Image opening is something you do in OpenCV. And then feeding them to OpenCV's simple blob detector, you get a whole ton of coordinates, basically. For each one of these blobs, it detects where it is, and will tell you where exactly in the image, X and Y coordinates, you should look for it. By calibrating consistently across the whole board for every single set of coordinates, you can register every single dot in the projector space to a corresponding spot on the image you're going to take. So at the beginning of the game, just for 30 seconds, it boots up and calibrates. It sets all these dots across, sorts them by height, and then registers each of the points to the key point. So now I know where to look. Next thing is I know what to look for. The first thing to do is to translate from the RGB space to HSV, giving us a single value that dictates what a hue is, or what a color is. It corresponds to the wavelength of the color. I can mask on a particular range. So for example, if I was looking for my orange token, I could say, okay, show me all the pixels that have a color range between 10 and 20 if the base color was 15. I can ask the board to show me exactly only these pixels, and I can detect them. So let's see what it looks like. This is a picture of the board. It's dull, it doesn't stand out very much, and it's kind of hard to see what the tokens are. But this is what the camera's seeing. And you kind of have to jump into the camera's view to make sure you're processing in the same way. If I apply this masking to the orange color we'd specified, it's amazing how quickly and how accurately you can look at all just the orange tokens. There's a lot of tutorials for this on YouTube, so if you ever wanted to go ahead and look them up, there's a million ways to do this. But the key point is that you do this for all of the colors. And by doing it for each of the colors individually, you can track exactly what colors are present in each of the key points by counting the number of white pixels. But I got a couple warnings for you. The first is that paper is really shiny, and that caused a lot of problems. Luckily, I live with an illustrator who is kind enough to point out that if I used a matte finish on the tokens, it might resolve a lot of these problems. So I walked down to the art supply store and I painted all my tokens with this matte finish. And I wouldn't say it solved the problem, but it certainly helped. The next is that you should make sure you manually set your camera. It's amazing how much the variance is between pictures in the camera. The auto white balance will suddenly increase the picture to be really bright or really dark, or shift the colors weirdly, or put gains on weird things. The big problem with this is that it can cause huge swaths of the board to be registered as one particular token. And this is going to cause problems because your token is going to be detected in not just one key point, but all across the board in a vast arsenal of key points. Other things to set include the auto white balance, the ISO, and the shutter speed. When you approach a project, there's two options for making it. The first is probably the easiest one, obviously, the most efficient. You make a single function which does literally everything, and you just call that. And that was obviously the way I should have gone. But I also wanted a working game. So I tried to encapsulate all of the things that were associated with image detection and image processing, including all these simple blob detections or all the thresholding, into this library lib/calibrate.py. So if you want to know exactly how I went about this, I know I haven't shown you any code in this presentation. This is the place to look on my GitHub page, and it's pretty well commented. You can see exactly how I've gone about the processing. So again, feel free to steal what you can. Last, I'm just going to mention the major libraries that I had in this game. But I don't want to disrespect the other libraries in Python because people put a lot of work in. Really, every library is an essential library. These are just the libraries that I found essential in my game. OpenCV to do the image processing. Pygame did all the graphical displays, and I found it very intuitive and easy to use. IterTools was useful for generating those color tokens and printing them off, so you can print them off and make tweaks as easily as you want. And then the PyCamera to capture the images. That's what I've got for you today. I want to thank you to the volunteers who, like every year, there's a whole ton of volunteers who make this possible. Red Blob Games is a guy who runs a website. Talks about all these image transformations or coordinate transformations to convert between, say, a hex space and a Cartesian coordinate system. And Millionth Vector, who provides a whole ton of free sprites online if you ever want to make a game. He doesn't even ask that you reference him, just it's a good guy to go to. And then I want to say thank you for coming to look at my talk, and I hope you guys enjoy the rest of PyCon. This is my GitHub page, and feel free to drop me a line if you're ever interested in learning more about this project or any other project I work on the side.
Okay, so we've got some time for questions and answers. Anyone?
What's the board game like? What kind of board game is it?
What kind of board game is it? What's it like?
It plays pretty well. So it's basically a resource collection game. So you control your units, you control your planets. There's a big fog of war that kind of occludes the rest of the game, which is randomly generated. So as you move your tokens through the game, you discover planets, you capture them. Each token or each ship has its own stats. And as you upgrade yourself, you'll notice that your fleet quickly becomes out of date. So if you had a certain technological level when you built that ship and you launch it, that ship never upgrades until you bring it back to your homeworld and upgrade it. So the idea is that it's supposed to be kind of like a semi-realistic, space game where you're slowly exploring at a limited speed the rest of the galaxy and encountering these other races. Yep.
Any chance it's like Twilight Imperium?
Any chance it's like Twilight Imperium?
Have not played, don't know. Is it? Gotcha. Yeah, so it sounds like Twilight Imperium's a very long game. This one, it took us about 2 hours to play through. That's because we were going really slow and taking our time with it. In the end, I think it would be much better to have it mounted. So right now you projected a screen and you kind of stick with duct tape or electrical tape all these paper tokens on the board. And it's slow to move around, and eventually they get like loose and wiggly, and then they fall down to the ground and you forget where they were in the first place. So ultimately, the idea is that you'd mount the projector on the ceiling, and all you do is turn it on. It calibrates on your table or on the ground, and then you just slide tokens around the ground, which can be printed on like blocks or whatever you want. Please.
Which game did you base it off to make this?
I guess just any games I'd played. I don't know. I really liked, for example, Eclipse was a great game I played. I don't know if you guys have played it, but it's a long game, strategic. There's a lot of components. Certainly, I could see myself including a lot of the things in this game like they had in that game. But also, I mean, the hex tokens are a pretty popular thing to use. I just tried to take what I liked from other games and put it into this game.
Have you dealt with dice at all, or other more like something like dice now?
Have you dealt with dice or other tokens like dice?
Yeah, that's a good question. And maybe part of the question is also, is there any random element in the game, or is it just like a strategic, like a game of chess almost? Yeah, there's definitely random elements in the game. So like the damage the ship does is randomly generated, and it is obvious what damage the ship has done. So each of the ships, you might notice each of the things on the board has a ring around it, and that ring is a health bar. So as the ship goes about its mission, slowly the health bar turns more and more green, it gains health. When it starts a combat, by just entering the zone of a rival unit, it'll take damage, and you'll see that because the ring will start fading to red, and eventually the ship will be destroyed. In terms of actually physical dice and rolling them and having the camera detect them, I didn't get to that just because the camera is quite far from the actual screen to get like a wide projection. So I was worried that I might miss. I know there's definitely a charm to having a physical dice that you can roll and see the result, and but in this so far, it's only randomly done in the background, and then you see the result. And you hear the cues, you hear when a ship has shot on another ship, or you hear when a ship's been destroyed. There's a little, audio cue that comes through as well.
So, would you say this is like an augmented reality type of thing? And have you tried adding really cool visual effects to the sketch?
Would you say this is an augmented reality type thing, and have you tried adding really cool visual effects to it yet?
I'd say it could be something like an augmented reality. I mean, certainly you're moving these tokens and it's painting them on. As you move the token across the board, the ship follows them. So, I mean, it's almost like you're moving the ship and not the token. But in terms of really cool graphics, I thought they were really cool. I'll work on it.
Do you think it's possible to get this working with a cheap projector, and how much do you think the projector would cost?
I totally think it's possible. It's easy. I think the only limiting factor really is the quality of the camera. The projector is really just going to control how bright it appears to you or how much resolution you can get. Maybe if you had a really low quality projector, you might not want to use a sprite. I mean, even here, it's a picture of a projection, but you can see it's not perfectly resolved, the ship. Conceivably, you might just want to use a colored dot for a ship or something like that if you're using a lower quality projector. And the price point is pretty low for those LAG projectors. So I think for $100, you could probably get something which was a small portable unit. Yeah, I haven't looked towards productionizing or selling this kind of thing. It was just kind of a fun project. I don't know if it ever would be realistic, except perhaps in a board game cafe or something.
Are there any more questions? No? Okay.
Okay, thank you guys again.